Welcome back to IT 3000. Today we're taking on one of the most quietly powerful ideas in Unix, the claim that everything is a file. A keyboard, a printer, a network card, even a source of random numbers, they all sit behind the same interface and they all answer the same simple call, read. Over the next few minutes, we'll unpack why that design choice still shapes the systems you use every day. So let's pin down what the principle actually says. Devices, kernel state, communication channels, services, they're all reached through one namespace and one tiny vocabulary: open, read, write, close. And here's the reframing that matters. This isn't a philosophical claim about what these things are. It's a decision about the interface they're required to present. Different resources, same contract. So what does that contract actually buy you? Four things, really. One vocabulary: open, read, write, close covers disks, terminals, sensors, kernel counters, all of it. One permission model, because device access rides on ordinary file permissions, so there's no second authorization system to learn or audit. Composability, since pipes and redirection work precisely because every program speaks the same interface at both ends. And one toolset, cat, grep, and ls, operate on hardware and kernel state without ever being modified to do so. But it's worth being honest. The principle doesn't hold everywhere with equal grace. Ordinary files are the perfect case, the one the abstraction was built for. Character devices mostly fit, though they lean on IOCTL, a system call that essentially means, do the thing this interface can't express. Sockets broke the pattern outright. You don't open a network connection, you socket, bind, and connect. Modern interfaces like ePOL and IOUring hand you descriptors that were never files at all. And Plan 9 went the other direction, pushing further, making even the network a tree in the file system. Still, when the principle does hold, the results are almost startling. Consider screen brightness, a value sitting in a hardware register on your graphics controller. The driver exposes that register as a file under basis snake class ne backlight with ordinary permissions. You echo a number into it. The shell redirection becomes a plain write system call. The driver parses the text, validates the range, and programs the register. The screen dims. A 12-character shell command just reconfigured hardware with no SDK, no library, no bindings in sight. Before we go further, it's worth separating three things people often blur together. A path is just a name, resolved once, at open, which is why you can delete a file while a process keeps happily reading it. The file descriptor is a small integer, private to one process, indexing its table of open things, and behind that integer sits the open file description, the kernel object that actually holds the position and flags. Fork shares that object, which is why parent and child can walk each other's red cursor. Keep these three straight, and half the surprises in Unix I/O stop being surprises. With that foundation in place, the rest of the series almost writes itself. File descriptors get their own episode because that integer deserves a closer look. Then pipes and named pipes, where the file interface becomes a channel between processes. Unix sockets extend the same idea to the network. IOCTL is the escape hatch for everything that doesn't fit the read-write mold. And Plan 9 is where the principle is taken to its logical conclusion. Next up, the file descriptor itself. So, three things worth carrying with you. First, the principle is about interface, not essence. It says nothing about what a resource is, only about how it must present itself. Second, the payoff is longevity. A tool written in 1975 still operates on hardware that didn't exist when its author retired. And third, it's not universal. Sockets never quite fit, IOCTL is the admitted escape hatch, and modern descriptors have quietly dropped the path. One interface for almost every resource on the machine. Thanks for watching.